Hey everybody, welcome back. This is Mr. Schultz here with you. We're going to take a look at 7.2.3, and we're going to be talking about the period of a cyclical function. So we touched on this word last time, the period. That's just that. How long is it for something to make a complete a complete rotation almost through that cycle? So just what is that length there? I've been mainly drawing these sine graphs. It could also be a cosine graph that would end up looking something like that too. But same type of idea, just shifted left to right. So let's take a look at these here. We'll start with question number 138. The input is angle theta in the unit circle, and the output is the cosine uh, of theta. So if I think about that, I'm just talking about the input. Well, that's just the unit circle, and the output is the cosine. So I'm just really talking about the cosine graph. So the cosine graph would be like this. It would start at 1 because the cosine starts here. Then as it moves through here, get down to 0. And then let me do this in a different color. Hopefully we can see this a little bit better here. So this first, let's not do that color. Let's do this color right here. I got it. I can do things. Here is our first little bit there. We get down to 0. And then it would start to increase again into the negative region. And then it would get back to 1 and go back down here to 0. And then, of course, it would finish back up where it started. And there is your cycle of cosine. That'd be just its normal 2 pi. Next one, the input is time and the output is the average daily temperature. This is kind of hard to think about, but if we think about like temperatures in New York, maybe here is 0. If I'm starting in the summer, let's call this the summer. And then, then you'd have the fall and you have the winter and so on and so forth. Well, the temperatures are probably highest in the summer, then they start to fall off in the fall, then in the winter. Maybe there's a couple that get below 0, but then they start to climb back up in the spring, and they'd end up probably back where they started in the summer. So I would say that the period here would be 1 year for that. And then here, this is that blood problem from the very first section. So that's that. So that's that baggie that's kind of sliding back and forth on the pole. It's essentially like doing this as she walks down the center of it there. So from there, it just depends on how fast is she walking. So just kind of what is the walking speed. Of these three, if this is one that I'm kind of least concerned about, these two hopefully kind of get some sort of a level of an idea there. Let's look at the next one, and FYI, this is a little bit of a longer section. This was supposed to be a 2-day section, so that's why it's going to be a bit of a longer video this time around. Let's see our next one, 139. All right, let's take a look at this next one, 139. Make sure your graphing calculator is in radian mode for this. I'll show that in just a second. But set the domain and range of the viewing cycle in the window so that you would see just one complete cycle of this equation, sine of x. So basically, we want to see just one cycle. So one time from here to there in this viewing window. So right now we see a partial here, and we kind of see, 1, 2, basically 3 of these things. So we want to change that so that's just 1, and then use that to find our domain and our range here. So let's take a look at this here. So when I click on my calculator and I grab this, I'm going to click here and make sure that it's in radians. So I'm just going to, so if it's in the degrees, I'll switch it over to radians there. And I'm going to start x from 0, just so that we kind of have that starting point there. And then here we know that the cycle length, or that the period length of sine of x is going to be 2 pi. So I'm going to just put that in as just pi, 2 pi. And now here's a thing that I find to be helpful. If I look at this graph now, it's a little bit hard to tell, oh, like this is 3.14, but like it's kind of awkward to count by ones when we're kind of counting by pies here. So here is my hint to you. You can go to the step thing and just put that in by pi. And that will start to make that x-axis count by pi. So now here it's crossing exactly at pi, it's crossing exactly at 2 pi. So our domain for one cycle, it starts here, it goes up, and this is not one cycle because it hasn't come back from this negative land, and now it's there. So our cycle here is going to end up being 2 pi. Again, if you didn't know that, that's okay. You could obviously just kind of zoom around on Desmos until you get there. Then the next thing is the range. Well, the range is my y-axis. Well, it looks like it's going up to 1 and down to a -1, but of course we can change that as well, make this a little bit make this a little bit tighter. So let's call it like -2 to +2, just so we can see it a little bit more clearly here. And sure enough, yep, it peaks out at 1 there and goes down to -1. So my range here would be that my y values would be between, so let's see, so y would be greater than or equal to a -1, because it does hit exactly on that, and it would be less than or equal to a +1 from there. So that would be my range there. This is a negative sign, not a multiply sign, but yeah, that is a negative. So let's take a look at the next one. And I guess before I go on here, I should say that my x value would be something like this. It'd be less than or equal to, so 0 and then less than or equal to 2 pi. There would be that kind of official domain there. We kind of talked about that, but I just didn't write it down. Okay, now we're ready to go on to the next one. All right, team, here's our next one. We're going to take a look at this one here. It is going to be graphing these equations here. So I'm just going to do one of them, and then I'll show you how to do the rest of them from there. So I didn't really show this on last time, but I'm pretty sure you know how to do this. You can either go down here and just type in sine of x. They also have back here in the functions, just right at the top there, the trig stuff. This is a scrolling bar, so you can find more things there, but I'm just going to go sine of x, and there we go. There's our first one, and I'm confident you guys can type in the rest of them, so I'm going to pause the video and type those in. Okay, team, so I went and I set up all these graphs. It kind of looks like chaos here, but hopefully you can see a little bit here. So the red one is kind of our default. The blue is that kind of half, so it looks like we're doing that. 2 is green, 3 is purple, and so on and so forth. So how many cycles of this appear on the screen? Well, of course, my range and domain is set from that previous problem A. So again, I've got my screen ranging from that 0 to 2 pi for x, and I've got it ranging from, I set it from -2 to +2 for y, but just so I can kind of see it a little bit more clearly there. But of course, the actual range would be from -1 to 1. So let's take a look at this. So how many cycles appear on each screen? Well, in our first one, we would just have 1. In our second one, we would have half of 1. In our third one, we'd have 2 of them. Third one, we'd have 3 of them. Fifth or fourth one, whichever number one I'm on, the fifth one, we would have 5 of them. And I can show this a little bit more clearly just by hiding some of these here. Okay, so I went through and I hid each of the things here. So here would be our first one. So that's where we get the 1 complete cycle from. Then if I turn on the blue one, we've got half of that cycle. If I turn on the next one, I think it was green. The green, I've got 2 cycles there, and then 3 cycles there, and then I've got 5 cycles there. So basically that number out front there just kind of is what we found from the first part, or from the lesson last time, that hey, that number next to that x there, that's what's increasing our number of cycles or periods that are happening per time through the rotation. So next up, we've got the midline here. It's the horizontal axis goes through the center of the graph. So what thing is going through the center? Well, that's just the horizontal line here. So the horizontal line would just be at y equals 0. That is that's the same thing as the x-axis. All my y values here are going to be 0, so that's what's going through that kind of center part there. And then it asks for what's the amplitude. That's the height above the midline of each graph. Well, in this case, that would just be a +1. They're all just hitting right up to this +1 and then stopping, or down below. So that there is that. So then what is the period or cycle length of each graph? That is pretty much that is kind of like this problem, but it is different. So here, what is the period or cycle length of each graph? So of our first one, of sine of x, well, we know that that's equal to normal, just 2 pi. Well, now I'm going at half of my pace here. So I need twice as long to be able to get my full period. So I need a 4 pi there. Then on my next one, where I am doubling the speed at which it's going, so I'm filling up 2 of these inside here, well, then I need half of that distance for the period length. So that would end up being pi. Let me pull this up on Desmos here and hopefully not look like a fool, because sometimes these things are hard to click. So here, to follow one period here, I just need to go up and down and there, and there we go. I finished at pi right there. Then when I get to my next one here, man, these things are so annoying sometimes. Here we go. Let's try this again. Okay, so now when I get to this, now it's not going to be quite as easy to find. So I started at 0. I went here, and here I am back through. Oh, wait, it actually isn't too bad. 2 pi over 3 here. So for my next one, where I've got sine of 3x, that period length is going to be 2 pi over 3. Then my very last one here that I'm going to do is I am going to grab this one. I'm going to find out, where do I finish my cycle here? Well, this one is going to be a little bit more complicated, because here I've got this, goes back through, and it finishes somewhere after this. So what I'm really saying here is that if I'm going 5 times over 2 pi, so I can get 5 cycles over 2 pi, well then my sine of 5x, if that normal pi length is 2 pi, well then I'd say I can do 5 of them over 2 pi, so I'd end up with this, I'm saying this backwards here. I would end up with 2 pi divided by 5 would tell me what one of those cycle length is there. So that's why I'm ending up this kind of weird value here, because 2 pi over 5, that's about 0.4, which is pretty close to 0.3, which is why it's close to that value right there. So that would be my cycle length there. Of course, the eraser is massive, and I delete exactly what I'm trying to do here. There we go. So that is that. Very last question here. Is each of these a function? Well, yeah, because every input has exactly one output. Every one of these would pass the vertical line test. They would never touch twice. Okay, that's part B. Let's go to part C now. Okay, so all three of these things are just kind of asking the same thing. What is the relationship between the period of the sine graph and the value of b in its equation? So when we had those pieces there, we had just normal sine of x, and that was equal to 2 pi. Then we had that sine of 0.5x, and that was equal to 4 pi. Then we had that sine of 2x, and that was equal to just pi. So basically what this is saying is that if we change all those, we're trying to say, what would sine of b of x? And in this case, b, we're just saying it in this case represented 1, 0.5, 2. We had those other ones with 3 and 5. And on that last one, 5, you saw me do this. Hey, I just need to take that cycle, that normal cycle length, and divide it by that value. Well, does that hold here with our 3? Well, let's see, we had 2 pi over 3. Yep, hey, that was that exact same thing. Hey, 2 pi over 2, well, the 2's cancel, and I made pi. When I have 2 pi over 0.5, well, that's going to equal 4 pi. So our conjecture here is that if we have this value b, if we've got some number before x, to find its period or cycle length, I just need to say that the period length, that's not supposed to be another I there, that the period length is going to be equal to 2 pi divided by b, and that is going to tell me what that period length is. These questions here are just trying to lead you more. If you didn't quite find it, then you make some more examples, and then just eventually here just stating this length. So this is our big key topic here. It's just that to find the period length or the cycle length, well, I just need to say with 2 pi divided by that number that I have right next to x inside of the sine parentheses there. All right, let's go on to our next one. Question number 140. Okay, so on this problem here, it's referring back to that kind of that swinging bag problem that they keep referring to over and over and over again in lesson 711. So this just kind of depends on your values. If we would have done this as a class, you would have had a range of values for how far that bag swung, and basically that would just be choosing your kind of domain and range to see, okay, did it swing out by, did this bag swing a total of 2 feet, like left and right, which means that it would have gone up 1 here and down 1 here. And so then you probably would have set your x or your y values that maybe you were counting by 0.25 or something like that. And then how long did it take you from your walking speed going this way? Same type of thing there. And then from that, you could start to write the equation. So you'd have that y is equal to, you should have that sine of x. You might have used cosine of x. That's kind of what they're hinting at here, because maybe your bag started like swinging like that, and the cosine just starts up versus the sine graph just starts at 0 and goes up and cycles through like that. Whereas the cosine graph, I am off here, but yeah, does something kind of like that. So so all this said, we would go and we'd find out, hey, what are those shifts? What is it? What's its period? What's that b? And then we want to add those shifts in, so minus that horizontal shift. Maybe we had it going up and down because we didn't think about this as being like as basically going down. So maybe you started your graph and it looked more like this, and it swung, this way, then that way, then this way, then that way. So then I need that horizontal k change there, or not the horizontal, but the vertical shift in different pieces like that. And then you might even need that a value all the way up out front, depending on how far it was swinging. Was it just going that plus or minus 1 foot, or was it going, was your bag swinging more? Was it going like plus 1.5 or something like that? So all this is just basically get back to this equation and say, hey, we have built this thing out, and we identified this, we identified this, we identified that. All of that is normal to the to like a parabola or some other equation there. But this is really our new piece. That is that period or that cycle length that is happening there. Let's go to the next problem, 140. So without a calculator, describe each of the following functions by stating the amplitude, the period, the horizontal shift, and the vertical shift here. So we haven't talked a ton about amplitude. We did mention it, but that is that kind of a value that is happening out front there. So that's that height there. So we're just going to go through and we're going to describe all these things: the amplitude, the period, the horizontal shift, and the vertical shift, which they're calling the midline. So let's try it on the first one, and then I'll just show you the answers on the other one and just kind of briefly talk through them. So let's take a look at A here. So on A, I'm going to take a look at this. So starting with the amplitude. So the amplitude here is just going to end up being 1, because it's not that, because it's got nothing out front here. So my amplitude is just kind of normal 1 there. My period is going to be, okay, well, that's that 2 that is happening out front here. So remember, that's 2 pi divided by 2. So my period is going to be equal to pi. Then my horizontal shift, that's that h value there. So that is going to be, I'm just going to do an h there. That's going to be increased by pi over 6. So it's going to go to the right, pi over 6. And then the midline, well, this would just be a plus 0. So my midline or my vertical shift would just be at 0. And let's take a look at this on Desmos and just kind of check out, make sure that all this thing tracks here. Okay, so taking a look at this, here's our equation. It looks just like this. Yep, it's shifted just slightly off there. This is pi over 2, so pi over 3. So pi over 6 would be something like right there. That is that shift that is happening, because now it's starting off. It's shifted to the right, because this would normally be the starting point. So there's that horizontal shift. The vertical shift, well, it's just going right down the midline, so nothing there. The amplitude, it's still at 1. It's going from 0 up to 1 there. And then our period is just pi. So I'm starting at that pi over 6, going through here and finishing out. I'm finishing out again at that pi over 6, and that's happening from pi over 6 through pi, and then add one more pi over 6. So that would end up being 7 pi over 6 or so. My period there is just pi length there. So that's that. So try these first without Desmos, and then you can like confirm your answers after that. Let me show you the rest of the answers here, and then I'll just chat through maybe a couple of the weird ones. All right, team, here are your solutions. Most of them are pretty straightforward. B just works like that. C just works like that. D, E. And then when you get down to F, this is where it starts to get a little weird. So let's take a look at F here. So first thing that I'm going to point out here is that the answer key actually has these two flipped. So these two answers are supposed to be flipped. So my period is supposed to be pi, and my horizontal shift is supposed to be pi over 4. Okay, so now just kind of looking at that, that's going to be kind of your first key there. And see if you can take a second and figure out why do they have it as pi over 4 when we see pi over 2, and why do they have the period as pi when we see this 2 here? It's like, how is that playing in? So let's take a look here in just a second. And I'm just going to jump right back here because you can pause it if you want to take a look at that. So here, what I noticed about this is that, hey, I could factor something out. I could get it into like a distributive property look here. And I would end up with something like this. Oh, hey, this 2 is being applied in both of those spots here. So I have to think about my period as to what's being applied to both pieces. So just like here, this 1/2 would apply to both of those pieces there. And this 3 is applying to both of those pieces there. So I have to be careful about things like this, just grabbing this 2 and just grabbing this, because this 2 is only applying to the x. It's not actually applying to both pieces like this one is. This is actually applying to both my pieces inside here. This 4 is applying both my pieces because it's just plus 0. So it's like nothing is happening there. So just make sure this b value is hitting everything inside of here, the x value plus the horizontal shift. Now this will make more sense because then we take our 2 pi divided by 2. Well, that'd be equal to my period length of pi, which we have there. And then, of course, we have our pi over 4, which would be equal to our pi over 4 there. Let's take a look at the next one. All right, guys, we are almost there. So this problem here is basically doing exactly what we just called out in the last one. So we have a line here. We've got amplitude, we got the horizontal shift, we got the midline, we got these two equations. And this is exactly what I talked about with the whole, hey, this 2 is only applying the 2 that is supposed to be for the, where am I seeing it? Oh, for the period. So this 2 is applying to both of these pieces here. This 2 is only applying to one of these pieces, which is causing your horizontal shift to not be the same. So in this case, Farah is correct, and then this one will just have a different period. And I think that you're able to graph that in Desmos and just kind of see what that difference is. Let's take a look at our very last problem because this video is super long and we got to be done. Okay, last one. Look at the general equation that you wrote for the sine functions in 114, which was a couple lessons ago. And now write your new parameter. I've kind of already done this, but y equals, you've got amplitude sine of x, sine of x minus h, which is that horizontal shift, plus k. So that was that standard one there. We just added this b part. It's going to go outside. Make sure that b hits both of those pieces there, just like we saw in that last example and the example before that. So just the b, that is that period. That is what is our newest piece here. That's everything that we got for today. So check out the review and preview, and let me know if you have any questions. Bye-bye.